Hello, this is a review of some of the things we've done in Unit 4. And the first thing is called Ohm's Law. And Ohm's Law is a mathematical relationship in a circuit between the voltage, current, and resistance of different components in that circuit. Maybe the voltage across a light bulb, or the current going through a resistor. Okay? And so a couple things to know before we get into Ohm's Law. There's a whole pile of letters and symbols that we need to understand. So let's think of something simple first. Mass is measured in grams. Okay, and instead of always writing out mass when we're doing a formula, we can just write m, lowercase m. Okay, that symbolizes mass. And instead of writing out grams every time, let's say we've got 100 grams of water, we could just say 100 G. Okay, so G is a shorter way of writing out grams. Now we have the same thing with voltage, current, and resistance. So voltage, instead of writing out voltage, we can write out capital V. And current, you'd think it would be a C, but C is taken up by other things like the speed of light and concentration and stuff like that. So current is actually symbolized by the letter capital I. Okay, so it's a capital I. And resistance is capital R. Okay, so we could find the voltage and current and resistance of different things in a circuit like this. Okay, now just like mass is measured in grams, voltage is measured in volts. And current is measured in amps. And resistance is measured in ohms. Okay, so these are different units for measuring voltage, current, and resistance. And just like grams, we have a shorthand symbol for that, little g. Volts is also, can be shortened with the symbol capital V. And amps can be shortened to capital A. And ohms, we use this Greek letter omega. Okay, so this means ohms. Okay, so, if we are trying to find the voltage across a light bulb like this, we can set up a voltmeter. And it could read 6V, which means 6 volts. Okay, and here 2A. A is amps, which is a measure of current. Okay. Now down here, this triangle with different letters in there, V, I, and R, that can be used to calculate voltage, current, or resistance. Okay, so different questions that you face will either be asking you to find the voltage, or the current, or the resistance. Okay, so let's try an example. So number 1, what is the resistance of the light bulb right here, which has 6 volts across it and 2 amps running through it? So the first thing I want to know is, what is this question asking for? And this question is asking for resistance. Okay, so resistance, I want to use this triangle to help me find the formula for resistance. So this is resistance. I can kind of cover that with my hand. So R equals V over I, right? V is up top, I is on the bottom. And so there is my formula. R equals V over I. Okay, so the question is asking for resistance, so I want a formula for resistance. And this triangle tells me that R is equal to V over I. Okay, the voltage divided by the current. So what is the voltage and what is the current? Well, voltage is 6 volts, and current, which is measured in amps, is 2 amps. So my next step would be R equals 6 volts divided by 2 amps. Okay, and then my third step is to find the resistance. So you can do this in your head, or you can use a calculator. 6 divided by 2, and that is 3. And the units for measuring resistance are ohms. So it's 3 ohms. Okay? So some questions will be asking for resistance, and then we do this formula. Some questions might be asking for voltage. Okay, and so the formula for voltage would be V equals I times R, because they're beside each other. And some questions might be asking for current. And so I is current, and so I is equal to V over R. Okay, so step 1, figure out what the question's asking for. Step 2, figure out your formula, and then start putting in the numbers in and calculate. Okay? Another thing we've been doing is on converting units. So, let's say that you drive 54 kilometers. How many meters would that be? Okay? That would be an example of what we're doing. Although in this unit we are dealing with volts, amps, and ohms. So, let's say we have a question like this. Convert 2.5 kilovolts to millivolts. Okay, kilovolts, that's a strong voltage. How many millivolts would that be? Okay, or if you think of it in another way, let's say you drove 2.5 kilometers. How many millimeters would that be? Okay, so we do these in 3 steps, and step 1 is write down the given measurement. So the measurement that's given to us is 2.5 kilovolts. Okay, so 2.5 kilovolts. The second step is to convert to the base unit. Okay. Now, what's the base unit for this question? We're going from kilovolts to millivolts. Is the base unit volts, amps, or ohms? Well, for this question, it is volts, right? Because we're going from kilovolts to millivolts. So I'm going to convert kilovolts to volts first. Okay. So what I want to do is I want to set up a big set of brackets, and I want to start filling this in. So kilovolts is up here. I want to put kilovolts on the bottom. Okay, and I'm going to do that every time. Whatever units are here, I'm going to put here. Okay, so kilovolts are here, and my base unit, volts, goes on top. But now I want to figure out which number should go in here. Okay, and so what I do is I think about which one is bigger, kilovolts or volts. Well, kilovolts are up here, volts are down here, and so whatever one is higher is bigger. Okay, so kilovolts are bigger than volts, just like kilometers are bigger than meters. So I'm going to put a 1 in front of the bigger one, and then I need to figure out how many volts are in 1 kilovolt. Okay, so kilovolts, there's 1,000. Okay, 1,000 volts in a kilovolt, because a kilovolt is 1,000 times bigger. Okay, so I put 1,000 in there. Okay, what this has done is now actually kilovolts, because I have it on top and the bottom, they cancel out, and I'm left with volts. Okay, and that's that you might not quite understand that, but hopefully the steps you can follow the steps. Now we're not trying to convert kilovolts to volts. We want to convert to millivolts. So we have to do one more step. Okay, because we want to convert to millivolts. Now, what units go on the bottom? Volts. Because whatever's up here goes down here, just like whatever was here goes down here. So volts go down here, and millivolts, our final unit, go up there. Okay. Now, the next question is, what numbers do we put in there? Okay, and every time we are comparing them on this chart, which you'll get for the test, and we're thinking, which one is bigger, volts or millivolts? Well, volts are here, millivolts are here. So volts are higher, so they're bigger. Okay, a volt is bigger than a millivolt. And so we always put a 1 in front of the bigger one. Okay, and now we have to ask ourselves, how many millivolts are in 1 volt? Okay, well, there's 1,000. Okay, 1,000 millivolts in a volt. Okay, now we want to calculate now. Okay? Because kilovolts have canceled out with kilovolts, volts have canceled out with volts, and we are left with millivolts. But how do you put this in your calculator? Well, you go 2.5 times 1,000 times 1,000 divided by 1 equals. Okay, so you're going to multiply everything on the top, divide everything on the bottom, press equals, and you get 2,500,000. Okay, and what are the units? It's these units. These are the only units left. Okay, millivolts. Okay, so there's a lot of stuff there. Try both those calculations and see if you can try some of them on your own. I hope it makes sense. Have a wonderful day.